Now let us discuss an application of dynamic programming problem. It is called cargo load problem. There are other applications as well, namely product allocation problems, long-term planning problems, then equipment replacement problem, etc. So we are discussing one among those applications. This is called a cargo load problem. A vessel is to be loaded with stocks of 3 items. Each unit of item I has weight Wi and value Ri. The maximum cargo weight the vessel can take is 5, and the details of the 3 items are as follows. Item 123, Wi 132. These Wi refer to the weight of first item. Weight of 1 unit of the first item, W2 is the weight of 1 unit of the second item, and W3 is the weight of 1 unit of item 3. So here we defined it in that way. Wi is the weight of 1 unit of item I. Then Ri is the value of 1 unit of item I. So R1 is 30, R3 is 80, and R1 is 30, R2 is 80, and R3 is 65. So we define Ri, it is already defined in the question, value is Ri. Now develop the recursive equation for the above case and find the most valuable cargo load without exceeding the maximum cargo weight by using dynamic programming. We can see that the maximum cargo weight is 5 units. Okay. So now let us proceed with the dynamic programming technique in order to solve the cargo loading problem. Now here we make these assumptions. We assume Xi is a possible weight of item I, Ai is the number of units of item I. Since we are dealing with a multi-stage decision making process, namely dynamic programming technique, we have to define the stages. So in stage 1 we will have, consider stage 1. In stage 1 we will have item 1 only. In stage 2 we will have item 1 and item 2, item 1 and item 2. In stage 3 we will have item 1, item 2 and item 3. So these are the 3 stages that we need to consider. Now let us formulate this cargo loading problem in mathematically. So let us write its mathematical formulation. Mathematical formulation of cargo loading problem. See, we have to find the most valuable cargo load. So the objective is to maximize Z is equal to A1 R1 plus A2 R2. Maximize Z equal to A1 R1 plus A2 R2 plus A3 R3. So as you can see from the assumptions here, A1 is the number of units of item 1, R1 is the value of 1 unit of item 1. So the total value of item 1 is A1 R1. The total value of item 2 is A2 R2, and the total value of item 3 is A3 R3. So we need the constraint, subject to the constraint A1 W1 plus A2 W2 plus A3 W3. So what is this A1 W1? A1 W1 is the total possible weight of the item 1, because W1 is a weight of 1 unit of item 1. A1 is the number of units of item 1. So total possible weight of item 1 is A1 W1. Similarly, total possible weight of item 2 is A2 W2, and total possible weight of item 3 is A3 W3. And we know that the total possible weight of this total possible cargo load on this vessel is 5. So the maximum value is 5. And since A1, A2, A3 refer to the number of units, so all these A1, A2, A3 are greater than or equal to 0. So we formulated the cargo loading problem in a mathematical way. Now let us solve this cargo loading problem. So in order to solve this cargo loading problem, let us adopt a very simple technique. So here I am going to list, so let us have the set of xi values Then we will write what is stage 1. Then we will write what is stage 2. And then we will have our stage 3. So now consider this table. So this table explains the procedure of this cargo loading problem. In stage 1 we know that we have W1 is equal to 1 and R1 is equal to 0. In stage 1 we consider item 1 and therefore we will have W1 equal to 1 and R1 equal to 0. So we are going to set this column for stage 1 into two parts. One is A1 and the other is F1 X1. So A1 and F1 X1. So let me have here the definition for F1 X1, F2 X2 and F3 X3. So F1 X1. So I shall have F1 X1 here. F1 X1 is the value of the item loaded. So in stage 1 we will have X1 X1. In stage 2 we will have F2 X2, value of the item loaded in stage 2, that is actually A1 R1 plus A2 R2, and F3 X3 is the value of item loaded in stage 3 and that is A1 R1 plus A2 R2 plus A3 R3. Okay. So that is how we define our F1 X1, F2 X2 and F3 X3. So here we have A1 and F1 X1 for the first for stage 1. In stage 2 we define the values for the item 2 and it is W2 is equal to 3. It can be seen from the question given. So W2 is equal to 3 and R2 is equal to 80. And therefore we are going to split our expression, our column into two parts. One is A2 and the other is F2 X2. Now for stage 3, our W3 is equal to, for stage 3 W3 equal to 2 and R3 is equal to 65 and therefore our A3 and F3 X3 are the columns required in stage 3. Now let us try to fill all the values. Okay, so we are going to start with our Xi values. So what are the possible values for Xi? See what is Xi? Xi is a possible weight of item I, and we know that the cargo can, the vessel can take only up to a weight of 5. So Xi values are 0, 1, 2, 3, 4 and 5. So these are the 6 possibilities for Xi. Okay. Now let us find our AI and F1 X1. So in stage 1 we consider item 1 only. So here A1, number of units of item 1 is 0. In order to have a cargo weight of 0 unit, then here we need to have 1 unit of item 1. Here we need to have 2 units of item 2. We need to have 3 units of item 1 in order to have a cargo weight of 3. Then we need to have 4 units of item 1 so as to have a cargo weight to be 4. Then 5 in order to have the cargo weight to be 5. Now correspondingly the value of the item loaded is 0 here. Then for 1 it is 1 into 30. See, this is A1 R1. So 1 into 30 it is 30. 2 into 30 60. 3 into 30 90. 4 into 30 120. 5 into 30 150. So that completes the stage 1. Now proceed to stage 2. See, consider in stage 2 we have the W2 of the item in stage 2, that is item 2 we are concentrating on. So for W2 the weight is 3. Okay, 3 units. Now in order to have the cargo weight to be 0 units, we cannot consider this A2. Now, in order to have the cargo weight to be 1 unit, again we cannot consider our A2 because A2 is our item 2, and for item 2 the minimum its weight is 3. So we cannot have this 1 as well. Then for 2 also here we cannot consider because our item 2 has weight equal to 3, and so when it comes to 3 we will have 1 unit of item 2. When it comes to 4, again we shall have only 1 unit of item 4, because if you take 2 units of item 2, the weight will be 2 into 3 equal to 6, so that exceeds this 4. So when when xi is equal to 5, still our item 2 we will have only 1 unit of item 2. Now let us find our f2 x2. So f2 x2, in this first 3 cases we don't have any f2 x2. So in the next case, when xi equal to 3, we will have, when x2 equal to 3, we will have 1 unit of item 2, that will give you 80. That will give you 80 into a1 r1. So I shall write it as 1 into 80 plus no other units, no unit of any other item should be considered. So 0 into 30, and that is equal to 80. Okay. Now when you consider xi equal to 4, we will have 1 unit of item 2. So 1 unit of item 2, it has value 80. Then 1 unit of item 2 will give you only a weight of 3, and therefore 1 more unit weight is required. So 1 unit of item 1 is also taken, and therefore as a whole the weight is 110. Okay. Then when it comes to xi equal to 5, 1 unit of item 2 is taken. So 1 into 80, 2 more units is required, so that 2 more units is taken from item 1. So 2 into 30, so 80 plus 60 equal to 140. So that is how we calculate the stage 2. Now coming to stage 3, for stage 3 we concentrate on the weight of item 3, and weight of item 3 is 2 units, and therefore for xi equal to 0 we don't have to consider. For xi equal to 1, again we don't have to consider, but for xi equal to 2 we do have to consider, because the weight of item 3 is 2, and therefore we need to take 1 unit of item 3. Now when xi equal to 3, again 1 unit of item 3 only can be considered. So when xi equal to 4, 2 units of item 3 can be considered. When xi equal to 5, 2 units of item 2 again can be considered, no more than that. Now let us fill our fi xi value. So for the first 2 rows we don't have any fi xi value. Coming to the third row, 1 unit of item 3 is taken, and that makes up the weight 2. So 1 into 65, that is equal to 65. Now coming to the next case, when xi equal to 3, 1 unit of item 3, that is 1 into 65, plus 1 more unit is required. 2 plus 1 is 3. So plus 1 more unit is required. So that 1 more unit should be taken from the first item. So 1 into 30, that is equal to 90. Now coming to the next case, when xi equal to 2, we have 2 units of item 3. So 2 into 65, then so 2 units of item 3 will give you a total weight of 4, plus 1 more unit is required. That 1 more unit will have a weight of 1 unit only, so that can be taken from the item 1 only. So this is one possibility, 2 into 65 plus 1 into sorry, it is only 4 units of total weight. So 2 into 65 is a possibility. So 2 into 65 gives 130. Now let me write here the other possibilities as well. You can take 1 unit of item 3, so that gives 1 into 65. Then so 1 unit of item 3 will give you a weight of 2 units. Then plus 2 more units is required. That 2 more units can be taken from the first item, so 2 into 30. So that is another option. So 65 plus 2 into 30, 65 plus 60, it is 125. So these are the two possibilities that arises in this particular stage. Okay, I hope you understand this. See, we need a total cargo weight to be 4 units, and therefore here we take two possibilities. We consider two possibilities. Either 2 units of item 3 can be considered, so which makes up a total weight of 2 into 2 equal to 4. So that 4 gets completely satisfied by taking 2 units of item 3. Now there is another possibility. You can take 1 unit of item 3, so that will give a weight of 1 into 2, and then 2 more units of weight is required, so that 2 can be taken from the first item. So 2 units of the first item will give you a weight of 2 into 1, and hence the total weight 4. So that is how we consider these two possibilities. Now coming to the last case, xi equal to 5, we can consider 2 units of item 3, and let us see the possibilities. So 2 units of item 3 will give you the total value as 2 into 65. So 2 units of item 3 will give you a total weight 2 into 2. So this is equal to 4. Now 1 more unit of weight is required, so that 1 more unit of weight can be taken from the first item, so 1 into 30. So this is one possibility. 2 units of item 3 and 1 unit of item 1, so that will give you 160. Now let us explore one another possibility. Let us have one another possibility, that is, we can have, instead of taking 2 units of item 3, let us try to take 1 unit of item 3. So 1 unit of item 3 will give you a weight 1 into 2. So this is equal to 2. So remaining 3 more units of weight is required. That 3 more units of weight can be taken from the second item. So that is 1 into the second item, 1 into 1 unit of the second item. So 1 into 80. So that is 65 plus 80. 65 plus 80. 80 is one option. So that is 145. So this is another option, and then there is one more option remaining. 1 unit of item 3. So this will give you a weight of 1 into 2 equal to 2. Then 3 more units of weight is required, so that 3 more unit can be taken from the first item. So 3 units of item 1. So item 1 will have item 1 is having a value equal to 30. So here 3 into 30. So 65 plus 90 equal to 155. So these are the different options. Okay. Now let me write here the optimum values. Optimum value. Now for the optimum value for xi equal to 0. So let us see which is the maximum value among the 3 stages. So optimum value of when xi equal to 0 is obtained here, and that optimum value is 0. Now optimum value when xi equal to 1 is here, since other columns do not have that xi equal to 1, so that it is 30. Then optimum value of xi equal to 2 is 60 here. Here there is a 60 and here there is a 65, and the optimum value is 65. So optimum value for xi equal to 3, for the optimum value for xi equal to 3, it should be compared between 90, 80 and this is 95. This is 95, not 90. 65 plus 30, it is 95. So this is the maximum value. So that is the optimum value for xi equal to 3. Now when it comes to xi equal to 4, we do have to compare 120, 110, 130 and 125. There are 4 values to be compared: 120, 110, 130 and 125. So this 130 is the optimum value. 130 is the maximum value. So we consider this 130, and that 130 is written as the optimum value. Now when it comes to 5, when it comes to the case of xi equal to 5, xi equal to 5, we do have to consider 150, then another option is 140, then we have 160, 145 and 155. So among all these values, 160 is the optimum value. So that's the optimum value, so we choose 160. So 160 is the optimum value. Okay, so we choose optimum values for all possible xi. Now let us find out the maximum of these optimum values, and maximum of these optimum values is 160, and so that is the optimum cargo value, most valuable cargo load. That's the most valuable cargo load, and so let us write down the most valuable cargo load. Most valuable cargo load. Most valuable cargo load. See that most valuable cargo load. This is the most valuable cargo load. So that means we need to consider 2 units of item 2, 2 units of item 2 and 1 unit of item 1. 1 unit of item 1. So that's the most valuable load. 2 units of item 2 and 1 unit of item 1. So let me write it as x1 optimal, that is equal to 1. Then item 2 units of item 3 actually. x2 optimal is equal to 0 and x3 optimal is equal to 2, and the maximum value is equal to 160. Okay, so that's the answer. I hope you understand this particular problem. The cargo load, since we have to, in this particular question we are given just 3 items, that is why we had here only 3 stages. So if the question carries more than 3 items, say if the question carries 4 or 5 items, suppose that the question carries 5 items, then you will have to do the procedure, we have to extend this procedure to 5 stages. And here we have xi as from 0 to 5, because the maximum cargo weight that we are given is 5. And that is why we have only up to 5. Suppose if in the question you are given that the maximum cargo weight is 10, then you will have to extend this to this from 0 to 10. So the problem will become bigger and bigger if you have more number of items and more cargo load. So this is comparatively a very simple problem to study how the cargo load problem gets proceeded. Thank you.